Ownbey. I'm the fire behavior analyst with the team. So a fire behavior analyst, I work with the IMET, get weather, and what we do is there's three components or the environment for fire behavior, and that's the weather, the other is the topography, and then the third part is the fuels. And when I talk fuels, that's the vegetation that's out there on the ground, the wood and the sticks and the brush that's growing and all those items that are out there. But what I look at is I try to model what the fire is going to do, how tall the flame lengths are going to be, because that's going to help keep firefighters safe. When they get too tall, if they're 8 foot tall or if they're in the treetops, then they can't get as close. When they're only 2 or 3 feet high, the firefighters can come in. And so I work with safety, I work with operations, I work with the PIO, and I try to get information and gather information and try to give them what I believe the fire is going to do and model that a little bit. So you just heard about the weather, and the weather is the one that changes the most. I mean, the wind is really a big factor in driving fires and makes them go. On this fire, we haven't had a lot of wind, so the driving factors for this fire have been the topography out there. And as you guys know, because you live around here, you look at these hills, the percentage of slope. I mean, if you're right in the bottom, it's 0, but right once you start, it starts to get up to 20s, and then you can have 80, 90% slopes out there very quickly, very easily. And you have some elevation gain with that as well. So these slopes, fire wants to go uphill. It doesn't want to move downhill like water. It finds the path that goes up, and it'll move uphill faster than it will downhill. So this fire has actually been on the knob and it's been backing down. So it actually has been moving slower as it backs down this hill for right now. If it changes slopes where it does get at the bottom of a slope and it's steep, then it's going to start to go faster and it's going to be more intense. The other thing that drives the fire in that fire environment is my fuels. And fuels, I'm not talking gasoline, I'm not talking oil or diesel. Fuels, the needles, the brush, the grass, the trees, and there's some large trees out here. And with this temperature that we've been seeing, we're seeing that is carrying the fire a lot. And then there's jackpots of it, where there's a lot of it down together. And a jackpot's just an accumulation of a lot of that. And if it gets under a tree, the trees have lichen in it. That lichen, it can actually just climb the tree like a ladder. It just climbs up. When it gets in the treetop now, it's throwing embers out. Makes it more difficult for firefighters to fight that. And so that lichen in the older trees here has been there for a long time. There's a lot more of it than in the younger trees. So it's going to throw those fires and embers longer. And as I was talking, you know, we got these fuels out there and we look at them, and those fuels, you know, like some of these that are about 3 inches, we call those 100-hour fuels, but they're dry. They're drier than normal. And then these that are a little larger, 4 to 5 inches, we call those 1,000-hour fuels from 3 to 8. And when I measure those, you know, we can actually take instruments out and we can actually, with a meter, and if you're ever trying to burn a fireplace, right? You guys have a fireplace. You try to burn wet wood, what happens? Doesn't want to go, doesn't want to burn. But this meter, I can put it into the wood and it'll actually stay in the green part here, and it's saying that it's like, when I measured it up on the fire when I first cut it, it was 8%. Typically those 100-hour fuels are 13, 18%. And so when they have dried out, they're going to carry fire. The other thing is this bigger wood doesn't gain moisture. So when the humidity comes in, it's not going to absorb that moisture. It's going to continue to be dry and to burn. So with this warm, dry conditions, guess what we're looking at for these things to do? Continue to burn for a long time. And the one thing that's going to change these, that's going to put an impact on this fuel source, is precipitation. And so when are we going to get that precipitation? Or when does that season-ending event come about? It's typically later September. You know, it's probably about the middle of September, about a 50% chance that season-ending event comes about. 28th of September, it's about an 80-90% chance. So duration-wise, difficulty-wise, this topography is making it really hard for the firefighters. The fuels are making it difficult, keeping it going, and the fire is probably going to be burning for a while until we get that precipitation that's really going to change these fuels that are carrying that fire. I will be around to answer questions afterward. Thanks.